We are back. We are back. We're so fucking back. We're back. Welcome to another episode of Pear Does, this time with a new mic, sounding new, sounding fresh. Let's get on the channel real quick. Let me pull that up. Make sure it sounds good. Welcome to another episode of Pear Does, this time with a new mic, sounding new, sounding fresh. All right, cool. We are sounding good. All right. So we're back. We're talking about AI. In this chapter, we're talking about semantic search, right? What is semantics? You probably heard of syntax. Syntax is typically the way things are written, how they're written, whereas semantics is the meaning behind what is written. And so if you've ever been a part of coding, you probably heard of syntax and semantics. But now we're talking about semantics in a way of looking for words or sentences based on their meaning, based on the semantics behind it. So in this chapter, we're going to learn how to use text embeddings to search for In this chapter, we're going to learn how to use text embeddings to search for the answer to a given query among the sentences in a data set. Remember those vectors. Since the embeddings take semantics into account, this process is called semantic search, semantics being the meaning behind those words. If you recall, you're not going to want to look at a bank of a river if you're talking about a bank where money is stored. So in this chapter, we're going to deal with unstructured text data on a regular basis, and one of the common needs is to search for information from a vast repository. A common approach is keyword matching, but the problem with this is that the results are limited to the exact query entered. So if I were to enter bank, it would only return bank back to me, right? It's going to match the word or words in those phrases, right? And so this is where we can utilize those text embeddings, those numbered vectors, as we learned in the previous chapter, where embeddings can capture the meaning of a piece of a text beyond keyword matching. If you recall, again, if we have bank, we're going to make bank 1 and bank 2. Bank 1 would be closer, in this example, to a river bank, and bank 2 would be closer to a money bank. And so therefore, if someone say, I want to withdraw my money from a bank, it's going to recognize the words withdraw and from and see which context, the semantics by which bank is being used, which bank, bank 1 or bank 2, should be used there, and then get the context that way. And so in this chapter, we're going to learn how to use embeddings to build a search capability that surfaces relevant information based on the semantics meaning of a query. So, step-by-step guide. We're going to use the same 9 data points from the previous chapter relating to airfare and flights, and pretend that those make up a list of frequently asked questions. Whenever a new query comes in, we want to match that query to the closest FAQ so we can provide the most relevant answer. And here's that list again, right? You can read through it. Show me a list of ground transportation at Boston Airport. Show me Boston ground transportation. This is all relevant to flying information. So let's say a person enters the query, how can I find a taxi or a bus when the plane lands? And so note that the taxi and bus keywords don't exist anywhere in these FAQs, right? We could control F. There's not going to be taxi. There's not going to be bus. So we need to see the results of what we get with a semantic search. Implementation-wise, there are many ways we can approach this. And in our case, we use cosine similarity. If you recall, cosine similarity is the angle or the distance between 2 points to indicate how similar those points are. If you recall the movie example, 2 movies that are completely unrelated to one another are going to be at that 90-degree angle, but 2 similar movies, let's say a sequel to one another, are going to have a very small cosine. And so in our case, using this cosine similarity, we're going to compare the embeddings, right, the numbers associated with those vectors of the word, right? So each word has multiple different attributes, multiple different columns of numbers associated with it, to compare the embeddings of the search query with those from the FAQs and find the most similar ones. So this is where we're going to get a little bit technical with it. All right. The first step is to turn the documents into embeddings. We embed each inquiry by calling Cohere's embed endpoint with co.embed. Cohere's embed endpoint is going to be just Cohere's embedding model, right? This is going to be how we embed those words or those phrases into those vectors. And this is something that Cohere has made and allowed us to use for this example. But we're also going to provide those FAQs as input and return the embeddings as an output. So again, we have those FAQs, those phrases, we're going to pass these into an embedding model, right? This model that is developed by Cohere in this example. They can be developed by a bunch of other uh, entities, but in this example, we're using Cohere. So you pass those phrases into the embedding model. The embedding model does its thing, and then it outputs these embeddings or these vectors, right, for each word and for each phrase. And so the three parameters that we're providing to the embedding model are text, the list of text that we want to embed, the model is which used to create the embedding. This is Cohere's embed endpoint. At the time of writing, there are 4 models that Cohere has available, and the input type. And so this input type specifies the type of documents to be embedded. And so at the time of writing, there are also 4 options. We can have a search document for documents which we want to perform a search against. We have a search query for query documents. We have classification for when the embeddings will be used as an input to a text classifier. And then we have clustering, right? For when you want to cluster the embeddings or when we want to see how close in different areas these embeddings are to one another. So this is just what that code would look like. We don't have to go too much into it, but you can see how they're defining this function of get embeddings, where they're calling the model embed English version 3, and the input type, we're creating a search document, and then more of that function, and then obviously the output here of get embeddings, where they're going to put it into a list. And so next, we're going to embed the query using the same get embeddings function, right, that Cohere provides. But now we're going to set the query. We're going to use set query as the input type, because now we're now embedding the search query. So, for example, define new query. How can I find a taxi or a bus when the plane lands? Remember, that is one of those FAQs that wasn't in our original list. And so then we're going to get embeddings of the new query. And so let's recall what is going on for a second. So the first example is we are creating a search document, or we are creating an embedding for the search document. The search document in this example is those original FAQ queries, right? All 9 of these. And so these query embeds, right, are going to be what we're embedding. And now we're going to embed the query. So we embedded the text itself, so the document. Now the user question, we're going to embed that as well. And so we're going to create an embedding for how can I find a taxi or a bus when the plane lands. And then now we're going to perform a search between the two. So we're going to say, let's create a function called get similarity that uses cosine similarity to determine how similar each of the documents is to that query. So we're stacking up that query of the taxi and the bus, the taxi and the bus against the entire document. And we've already embedded both. So what it's going to look at, it's going to look at all the cosine similarities of the document and the cosine similarity of the user query. And it's going to compare those to one another and see which one do we have that's similar. And so in this code, you can see we're going to calculate the cosine similarity between the search query and the existing query, right? Get similarity. What is the difference between the target being in this example, it's going to be our query. And in this example, candidates is going to be our array, our list, our search document, essentially. We're going to calculate the cosine similarity between the target and all of the candidates. And then we're going to return similarity scores between all of them. And so after that, we're going to say, give us the top 5 articles, the most similar documents in that FAQ. But in this example, we're just going to output all of them. And so below are the results showing the FAQs with the similarity score ranging from 0 to 1, higher scores being better, right? We have a ranking function in there. If we go back to the top, where we are wanting them to output, excuse me, we're wanting them to output or sort based on their ranking. You can see sort score here, similarity scores as well at the bottom. So we're going to sort based on that. And then the top three ranked FAQs we get are inquiries about ground transportation, as you can see here. Ground transportation, what ground transportation, they all have ground transportation in them. And so these are very relevant to bus and taxis, right? Taxis and bus are ground transportation. And so although our query of how can I find a taxi or bus when the plane lands doesn't state the words ground or transportation, the embedding model is able to embed those words very, very well, acknowledging the similarities between what a taxi is, what a bus is, and what ground transportation is. And so we're able to recall uh, those similarity scores and look at the how similar these phrases are based on how similar the words are in those phrases. And so notice that they don't contain those words as we stated, but um, they don't also contain ground transportation, but they are similar in meaning compared to the rest. And based on that cosine similarity score, we can see that, hey, we have a few that are more alike than not. And so after doing all this, while we can use the similarity scores and just look at the numbers themselves, we want to visualize the results in a 2D plot so that we can see where we sit and where the most likely answers are to be. And so after plotting this in a 2D plot, we can see that the query is located closest to the FAQs about ground transportation. All on the right here are going to be about ground transportation. All on the left are all other FAQs. So the query about taxi or bus is located closest to documents about ground transportation, which is true. Taxis and buses are ground transportation. So in conclusion, we learned how to use embeddings and similarity to build a semantic search model. There are many more applications of embeddings, which we're going to learn in following chapters. But the biggest takeaway here is that we can take a document, right, that is a standalone document, these FAQs that basically act as a database of answers that we have. We're going to embed everything in that document. We then take a user query, we embed the query itself, and then we tell the model, um, we use this function of get similarity, right? So we use the model. We then get a function called get similarity, and after embedding everything through the model, this get similarity function is going to get the cosine similarity between all the embeddings, all the vectors that we pass through the embedding model, and it is going to return those phrases that have the most similarity to the query. Something that's cool, something that I want to point out is that all of these, right, even the actual document itself, right, the input document, this FAQ, it doesn't have to be this. We could have passed anything through um, for our search document. We could have passed anything through for the search query, right? But just an example, we were just using those to stack up against one another. Again, going through this code, I know this is a little bit deeper into that, but if we look at the following, we can see that, right, we're getting the embeddings. We're going to use text as one variable, the model, which we've explicitly outlined here, as another, and the input type as search document as our third. Two of those three are already predefined, our model and our input type. So we can see what we want the embedding model to output, right? This co-embed, if we recall, that is how we're going to call this model. We want it to output the model. We want it to output the input type, right? Search document and the text. And so all we're saying is feed the model, feed the input type, and then feed those texts, these texts being this, feed those all into the model and give us an embedding, okay? And so we're going to create basically an array of those query embeddings. And so what it's saying here is let's define those and put those in a list. And that is how we get this bottom list of embeddings in a list. That search, we've already gone through it, but again, we're going to say, how can I find a taxi or a bus? This is our new query. And then we're going to create another function called get or new query embeds get embeddings. So we're going to pass into get embeddings the new query, right? The input type being a search query. And then we're going to also output this to an array. And then when it's going to compare these embeddings, it's going to get those similarities. We can see that we're using the cosine similarity. It's using something called squeeze. I don't know exactly what that is, but it's going to put it into a list. And then it's going to sort by index, and it's going to sort based on the score. And so then we have the similarity scores, which is going to be putting in the score index and the sort score. The index being that sort 1, 2, 3, 4, and then also the score ranking of, okay, we need to assign the most highly to one, and so forth. And so then when we're getting the similarity between the search queries, we have similarity, get similarity, new query embeds. It's all technical jargon, but at the end of the day, we know what's going on in these AI models. We've seen what's going on in these AI models. And now we know what's going on to at least know how they're getting responses of similar types, right? We haven't gone into how they're putting the words together. We haven't gone into how they're deciding what to respond with, right? These are only showing us similarities, but we know how we can kind of see, or we can kind of see how that's coming together, right? So if we can assume that how can I find a taxi or bus when the plane lands is similar to these three, we can start to see, okay, if there's another function out there that says, hey, return the most similar one, that would return a result, but it's not going to provide an exact answer. And so we also have these transformer models, which we'll learn at a later date, that's going to return or respond based on clusters, based on these cosine similarities, and generate outputs based on other functions and models that we have not talked about yet. Um, but that is it for today. It was short and sweet. Remember, this is semantic search. And next time, we will be going into text clustering. So if you recall, in our Cohere embedding model, we do have a input type called clustering, which we will be getting into more tomorrow, or actually more next time. We're trying to keep it to Fridays. Maybe you'll get an extra stream or not, but happy Friday. This has been Pear Does with a new mic. Deuces.